Good morning, dear students. I just welcome you all to the Department of Physics, Tipoi College. In the previous lecture, we have learned about the exact differential equations or exact equations, and today we will be learning about the non-exact equations. So, what if we have a non-exact equation? How can we reduce a non-exact equation into an exact equation? So, these things we will be discussing today. If you have a non-exact equation, in that case, we can reduce a non-exact equation into exact equation simply multiplying the non-exact equation with a suitable integrating factor. And to find that suitable integrating factor, we have to learn 5 rules. So that we'll be learning in this video lecture one by one. So let us begin. So rule number 1 is that if partial differentiation of m with respect to y minus partial differentiation of n with respect to x divided by n is a function of x alone, then integrating factor if is equals to e to the power integration f of x dx. So if we get this is equals to some function of x alone, so f of x is a function of x alone, then the integrating factor I dot f is equals to e to the power integration of the function f of x alone dx. So let us try to understand this rule with the help of an example. Suppose we have the question that solve 2x log x minus xy bracket close dy plus 2y dx is equals to 0. So if we have got this equation and we are asked to solve this, so how can we approach? Let us see the solution part of this. So solution, so here what is m and what is n? Here m is what? With dx we have 2y, so this is our m here, so I will write here m. And what is n here? So with dy this part is related, so our n will be equals to 2x log x minus xy. So we have got m and n. Now next step what we have to do, we have to simply take the partial differentiation of m with respect to y, and we will get it equals to 2. Similarly, when we take the partial differentiation of n with respect to x, we are going to get what? So I will simply perform the partial differentiation here. So 2 into bracket close 1 log x, log x plus x into partial differentiation of log x is 1 by x. So I'll be getting this minus y. So which will give me further what? So dn by dx is equals to, I can write 2 as common 1 plus log x minus y. So this is what I'm going to get here, dn by partial differentiation of n by partial differentiation of n with respect to x. So we see that here partial differentiation of m with respect to y is not equals to partial differentiation of n with respect to x. So it is an non-exact equation. So to get the solution of non-exact equation, at first we will check that condition which is given by the rule number 1. So I will simply first I will find the difference of this, that is partial differentiation of m with respect to y minus partial differentiation of n with respect to x, and this is equals to what? 2 minus 2 1 plus log x and here plus y. So this I am going to get here. So if I open this bracket, I will be getting what? Minus 2 log x plus y. So this is what I have got, the difference of these two. Now I will simply divide this by n and I will check what I am getting. So I will take this minus this divided by n. So what is my n here? I will have the value of n here as 2x log x minus xy. I can take here x common. If you see x and this x common, so I can write simply this in this way, that is minus 2 log x plus y, and if I take x common, I will be left with, as well as I will take minus also common, then I will be getting minus log x minus plus y. So the denominator part and the numerator part are same, so I can cancel this with this, and I will be getting finally what? Minus 1 by x. So this is what I have got finally. So this is equals to some function of x here. So this is my f of x. Okay. Now, so I have found that this is a function of x alone. So I can proceed now further. So what I'm going to do next, I will simply take the integrating factor. So my integrating factor I dot f is equals to e to the power integration f of x dx. What is your f of x? That is minus integration your 1 by x dx. This is equals to e to the power minus, so integration of 1 by x is equals to what? Log x. So this, and this I can write in this way, e to the power log x to the power minus 1. So we know this is equals to what? Exponential and log, they will simply cancel each other, and I will be left with x to the power minus 1, which is equals to 1 by x. So this is my integrating factor. Now I can reduce the non-exact equation which I have got as the quotient into an exact equation simply multiplying that equation with this integrating factor. So let us multiply. So multiplying the given differential non-exact equation with 1 by x, we get, so if we multiply, we are going to get what? 2y by x dx plus 2 log x minus y dy is equals to 0. Now this is an exact differential equation. Now to get the solution of this equation, I will go according to the rule of exact differential equation. So this is m and this is n. So I will be simply taking this m and I will take y as the constant here. So integration of 2y x dx plus integration. Now here in the second part, when I'm going to take the integration of n, then if you remember, we will be taking only the term containing y, not the term containing x. So this term will not be there. Okay, so it will be minus y dy. This is equals to 0. So if you do the further calculation, you will be getting what? 2y log x minus half y square is equals to some constant c. In the previous step, I'll make a correction. It will be c here. Okay, it will be c here. So this is the form of the solution of the exact differential equation, and this is what we have got as the solution of the exact differential equation. So this is the solution of the exact differential equation, and this is our final answer. Okay, now let us see the rule number 2. According to the rule number 2, that is rule number 2, if partial differentiation of n with respect to x minus partial differentiation of m with respect to y divided by m is a function of y alone, then integrating factor is equals to e to the power integration of f of the function y dy. So again we see similar type of condition here, that if this is equal to some function of y alone, then our integrating factor will be this. So let us try to understand this again with the help of some example. Say we have the question that solve y to the power 4 plus 2y dx plus xy cube plus xy cube plus 2y to the power 4 minus 4x dy is equals to 0. So suppose we have this question and we have to get the solution of this question. So what we will be doing again? Solution. Here m, again I will be writing m and n. So here m is y to the power 4 plus 2y, and what is here n? It is xy cube plus 2y to the power 4 minus 4x. So next, you know only what I will be doing. So therefore partial differentiation of m with respect to y, it will be 4y cube plus 2. Partial differentiation of n with respect to x is equals to y cube and minus 4. Okay, so if we take the difference of these two, let me write, that is partial differentiation of n with respect to x minus partial differentiation of m with respect to y. I am going to get equals to y cube minus 4 minus 4y cube minus 2. So this will be giving me what? Minus 3y cube and minus 6. So this is what I will be getting. So if I take now this, that is partial differentiation of n with respect to x minus partial differentiation of m with respect to y divided by m. So this will be equals to what? So here only you can see it is a purely a function of y. Okay, so certainly I'm going to get a function of y only. So that's why I've taken this. Okay, so if I would have got here x, then what would I have done? I would have taken partial differentiation of m with respect to y minus partial differentiation of n with respect to x divided by n. But since I've got purely a function of y here, so I am doing this. Okay, so don't get confused. Go step by step, you will be able to do it easily. So I will write here the difference part at first, that is 3y cube minus 6 divided by, what was my m? M was y to the power 4 plus 2y. So this was my m. So if I do the calculation part, so though it looks very complicated, but still we can solve it. Let me arrange the things. Okay, I will take here minus common, let me take the minus common and 3 common. Minus 3 is common, y cube plus 2. And at the below I will be having what? Y common, y cube plus 2. So this cancels out and I am left with minus 3 by y. So I have seen that I have got purely a function of y. So therefore integrating factor will be what? It is equals to e to the power integration of f of y dy. So what is your f of y? Here the f of y is minus 3 by y dy. So again I am going to get what? E to the power. So I will take 3 outside and 1 by y. So integration of 1 by y is log y. So this is equals to what? E to the power log y to the power minus 3. So again I will be getting what? Y to the power minus 3. So this is what my integrating factor is. Now I will multiply this integrating factor with the given question. So multiplying integrating factor with given non-exact equation, we get what we'll be getting. So what was the question? Let me write it again. It was y to the power 4 2y dx plus x y cube plus 2y to the power 4 minus 4x whole thing bracket close dy. So this was my given equation, and what I'm going to do here, I'm simply multiplying this integrating factor on both these sides in this way. Okay, I have multiplied the integrating factor. So if I multiply, I will be getting what here? Y plus 2 y minus 2 whole thing dx, and here it will be x plus 2y minus 2x y to the power minus 3 whole thing dy is equals to 0. So this what I have got. Now this is a exact equation. Therefore what we can write? Therefore solution of this equation is what? Integration of m taking y as constant. So if you see here, there is no x inside, right? So I can write integration. So I will be writing simply here this dx plus, here I have to take only the term containing y, not x, so it is only 2y. Okay, so I will be just writing 2y dy is equals to 0. So if you simply do it further, you will be getting here xy plus 2xy minus 2, and here you will be getting 2y square by 2 is equals to 0. So again I'm making the same mistake. This will not be 0, okay? This will be some constant c. So it is a constant c. Okay, so this is a constant c here. This is also constant c here. So finally my answer will be what? X y plus 2 by y square plus y square is equals to c. So this is the solution of this question. So this is how we have solved the non-exact differential equation by this method, that is by rule number 2. So for today let it be this much only. We will be discussing rest of the rule in my next lecture. So please practice these questions, and if you have any doubt, please let me know. So that's all. Thank you.